this analysis or this analysis, I think it's good for you guys to see both cases when the current is going this way or that way. So this is basically what's happening here. Now we can actually now turn the switch 3 on. When switch 1 and 3 are on, then both these switches are basically creating a short circuit against the load. So that's why the output voltage is 0, as we had before. Now, what do we want to do from this point to this point? Okay, we want to keep switch 3 on, but we want to turn 1 off and we want to turn 4 on. Okay, and so to solve that problem of having these two on unintentionally, what we do is we first keep 4 off and then turn 1 off and then turn 4 on. Okay, so we basically create at that time a delay between turning 1 off and turning 4 on. Okay, so that's basically what's happening here. So now we have only switch 3 on. In this case, I'm looking at this red line here in the state 2. I'm only having switch 3 on, which is this case. This switch is on. Okay, what happens if we have the current going through this way? If the current is going through this way, it's going to go through the switch, right? So we have our current going through this way. This current has to find a path through diodes. Which diode it's going to choose? It can't choose this diode. It has to choose this diode, right? So if the current is going through this way, this current, it's going to go from here into diode 4. It goes through the load. It goes through MOSFET 3, switch 3, and then goes back to the source. Okay, so if that's the case, right, what's going to be the voltage across the load? This point, it's going to be 0. Then we have minus FD, right? And over here, this is going to be connected to VDC. So it's going to be minus FD minus VDC. So it's going to be minus voltage drop on the diode and minus VDC. Okay. What if the current is actually, the current in the load is going that way? Switch 3 is on, so this switch is on, and we have a current going through this way. This current is now need a path to go through. This time it chooses this diode because this diode cannot let the current going this way. So this chooses this diode. So switch 3 and diode 1 are going to conduct. So in this case, again, we have a voltage drop. We have a short circuit, right? This is like the path for the current. So the voltage across the diode, this point has a higher voltage than this one. So the voltage, it's gonna be voltage of FD, right? The voltage drop against the diode is the only voltage that we have on the load. Okay, so we did that time. Now we have state 3 when we have switch 3 and switch 4 on at the same time. In this case, basically this is like how we have the current going through. So goes through switch 3 and switch 4. Let me make this more clear. Okay, so if the current is going through this way, it goes through here, it goes through switch 3, it goes back to the source, and then from switch 4 it goes back to the load. Okay, in that case, this voltage, it's connected to this point and this part of the source, and this voltage is connected to positive pin. So the voltage across the load, it's going to be negative VDC. Okay. So this hasn't changed. The parts that I have written in black ink, it hasn't changed. But it's the same as what we had for the ideal switch. But now, again, we want to go from this state 3 to this state 4. So we want to keep switch 4 on, but what we want to do is turning switch 3 off and turning switch 2 on. Okay, in order to avoid having both 2 and 3 on at the same time, we first turn switch 3 off, we keep 2 off, and then turn 2 on. Okay, so this is the state that we have now. It's like the middle state that we have. And in this point, switch 4, which is this one, it's on. Okay, let's assume that the current is going this way. Okay, if it's going this way from switch 3, it needs a path to go through. It can't go through diode 2, it goes back through diode 3, right? So now the path of the current that we have is from this switch, goes to the load, goes to this diode, and goes back to the source. So this is how we have the current flowing through the circuit. Now, what's going to be the voltage across this this load? This point, it's connected to the negative pin of the voltage. Here we have voltage of positive VDC. Here it's going to be positive VDC plus VFD, because we have VFD voltage drop against the diode. So this is going to be positive VDC plus VFD, right? And the notation that we have for our output voltage is like this. So this is going to be, again, negative VFD minus VDC. Or let me actually write negative VDC minus VFD. It's the same, but I just wanted to show you that this is like what's happening here. This is like VDC. This is going to be VDC plus VFD. Now this is going to be 0 minus VFD minus VDC. So 0 minus VFD plus VDC, which is going to be negative VDC minus VFD. Similar to the other two, we're going to assume that the current, if the current is going through this way, switch 4 is on. So this switch is on. Now the current is going through here. Which of these diodes are going to conduct? Of course, diode 2, right? So in that case, the path for the current, it's going to be through diode 2 going back to switch 4. So this is what we have. Again, we have a short circuit, but we have a voltage drop against this diode. So this point has higher voltage than this point. So the voltage that goes across the load is positive VFD. Let me write the positive so that you don't get confused. Okay. Perfect. So now this middle state is also gone. Let's go to our last state, state 4. Switch